class we are going to discuss about the topic conservation of momentum. Students, in this class we will discuss how the momentum remain conserved for a system. Students, in our previous classes we have discussed about the term momentum. We all have defined that momentum is the product of mass and velocity. We all have defined momentum P is equal to product of mass and velocity. If a body has mass as well as velocity, then there will be a term associated with it, that is the momentum. And students, we have defined that the momentum is the ability of a body to apply the force. Momentum defines the ability of a body to apply the force. Now we are going to discuss the conservation of momentum. Students, conservation of momentum states that whenever two or more than two bodies together combines a system. Suppose there is a system of two or more than two bodies, then conservation of momentum states that the total momentum always remain conserved. I repeat again, total momentum always remain conserved. Initial momentum will be equal to the final momentum. Consider we have two bodies. Consider we have two bodies A and B. These two bodies are moving with velocity u1 and u2. Suppose the velocity of A is u1 and velocity of B is u2. And these two bodies have the masses m1 and m2. Then what will be the momentum of A? This will be the m1 u1, and the momentum of B will be the m2 u2. Momentum of A is the m1 u1 and the momentum of B is m2 u2. Now, suppose these two bodies collide together. Suppose these two bodies now collide together, and now the velocity after collision, suppose after collision their velocities are v1 and v2. Suppose these two bodies collide together and after the collision their velocities are v1 and v2. Then the final momentum will be the m1 v1 and m2 v2. Then the force experienced by A and B during the collision will be, if you are going to calculate the force experienced by A and B during the collision, then we can apply the formula force is equal to mass into acceleration, and mass into acceleration, where acceleration is equal to v minus u by t. Acceleration is equal to change in velocity upon time taken. Then what happens? Now we are going to apply the force experienced by A and force experienced by B, which will be equal because according to the third law of motion. Third law states that the force experienced by the two bodies which are in the contact are equal and opposite. Then apply here the third law, then you will see that the force experienced by A will be equal to the force experienced by B with minus sign, because these forces are equal but opposite in direction. Then for A, mass m1, mass of A is m1 And what about the acceleration? Then you will write v1 minus u1 by t is equal to, for b, m2 v2 minus u2 by t. Mass into acceleration. Acceleration is equal to change in velocity, and here change in the velocity from u2 to v2. Then what will be the change? v2 minus u2. Here what will be the change in velocity? v1 minus u1. And keep here a minus sign. Now this t will cancel out. You will get m1 v1 minus m1 u1 is equal to minus m2 v2 plus m2 u2. Now here we are going to combining the terms u1 and u2 together and v1 and v2 together. Then when you will put this u1 term at the other side, you will get m1 u1 plus m2 u2 is equal to, and keep these two terms v1 and v2 together, you will get m1 v1 plus m2 v2. This is the result, students, and what this result is showing, you can see that the before collision the momentum was m1 u1 and m2 u2, and you can see that before momentum is the momentum before collision. If you sum these two momentum, then you will get m1 u1 plus m2 u2, which is equal to the sum of final momentum, and the final momentum is m1 v1 plus m2 v2. This is the conservation of momentum, which states that when two or more than two bodies combining together, a system are together, and then for that system initial momentum will be equal to the final momentum. And we can see from this result, this is the initial momentum of these two bodies, m1 u1 plus m2 u2, which is equal to the final momentum of these two bodies. Okay students, now we are going to discuss a small numerical problem which is based on the conservation of momentum. Students, the numerical problem is a bullet of mass 200 gram fired with a velocity fired by a gun. A bullet of mass 20 gram fired by a gun of mass 200 gram. Here it is given that the mass of bullet is 20 gram and the mass of gun is 200 gram. If the velocity of the bullet is 200 meter per second, velocity of the bullet is u1 is given 200 meter per second, then it is asking the recoil speed of the gun. It is asking the velocity with which the gun will recoil. Students, then we are going to solve this numerical problem. Then students, here it is given that m1 is 20 gram, and what about the initial velocity of the bullet? u1 will be 0, because when the loaded gun is in your hand, then at the starting position the velocity of the bullet will be 0, and as well as the velocity of gun is also 0. Then you will write here u2 is equal to 0. But after firing the gun, velocity of the bullet is 200 meter per second, and it is we have to find the velocity of what? Gun. Then we are going to apply the conservation of momentum. Initial momentum before firing the gun should be equal to the final momentum after firing the gun. Then right here m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. Isn't here we are going to substitute the values. m1 u1 20 into 0 plus m2 u2 200 into 0 is equal to m1 v1 20 into 200 plus m2 u2 m2 v2, and m2 is 200, and here the v2 is to be found. Then we are going to write it the v2. Then we are going to solve. This value will be 0. Then we will get 200 v2 is equal to 2 to the 4000, and this 2 will consider to 0. v2 will be equal to the 20 meter per second. This will be the recoil speed of the gun. Recoil speed of the gun is the 20 meter per second. In the same way, students, there are so many numerical problems, questions regarding the conservation of momentum. Then the concept will be same. First of all, find the initial momentum of all the components of the system and equate it with the final momentum. And by equating these two, you will get the desired answer. And thank you, students. Thank you for watching. Thank you so much.